In the previous video, we created a network on countries. We also stored the positive and negative signs across the edges. We also computed the total number of unstable triangles in the network. Our next aim is to move this network to a stable state. For that, what we'll do is we'll choose one triangle which is unstable and we will move it to a stable state. We will keep doing this until the complete network becomes stable. So we have to see how the number of unstable triangles fluctuates and how it changes with respect to each iteration. So let's get started on that. We have this variable unstable which keeps track of the number of unstable triangles. So we can start a loop here while this unstable becomes 0. So we can write while unstable is not equal to 0, we have to keep repeating this. Now what do we have to keep repeating? Since we have to repeat this, it will be better if we create a function for this particular task. So let me create a function here, maybe move a triangle to stable state. We need to pass the graph here because that is what we will get changed during this task, and we also need to pass all the triangles list. We might also need all the signs there. So let's pass this, and in this function we'll make some changes in the graph with respect to the signs of one of the triangles. So we do want the updated graph back, so this is the function we will just implement. Once we get the updated graph, that is once one of the triangles has moved to a stable state, the signs of the adjacent triangles might also get affected. So we need to recompute the signs of the adjacent triangles. So we can do one thing, we can do one of the two things. We can either recompute the signs of the adjacent triangles only, or we can recompute the signs of all the triangles. Here for simplicity I am recomputing the signs of all the triangles. So basically I'm going to call this function once again, get signs of triangles, which we have already created. So I'm going to call this once again on the updated graph G here. Also, once we get all the signs, we need to check how many unstable triangles are there now, right? So we need to get the updated count here. So we'll call this function count unstable once again. So now up this variable unstable has the updated count of the number of unstable triangles. So after that the control will go back here. If this is not equal to 0, it will go back again inside, where it will go inside this function, where it will choose one of the triangles which is unstable and will move it to the stable state, and so on. So this loop will keep running until the entire network becomes stable. So we are done with this part. We just have to implement this function now, move a triangle to stable. So let's see how we can do that. Let me copy the syntax. Let's go up and let's create this function. Now we have the graph G, we have the list of all the triangles, we have the list of all the signs on these triangles. Our aim is to choose one triangle which is unstable. Now how do we do that? So what we can do here is we can choose one triangle out of this list randomly, and then we can check whether this triangle is unstable or not. If this triangle is unstable, we have found a triangle which we have to work on. If this triangle is not stable, if this triangle is stable, we will check another triangle. So we have to keep checking the triangles until we get an unstable triangle. So how do we do that? Let's create a flag, maybe found unstable is equal to false. So initially we have not found any unstable triangle. We will keep running this loop until we find one. So right, while found unstable is equal to false, we have to keep running this. We have to keep running what? Basically we have to choose one triangle randomly out of it. So what we can do is we can make use of a function randin, which is there in random package. So maybe index is the variable that will store the index of the triangle. So So we can write random dot rand int. So we can start from 0, length of triangles list -1. So basically what we are doing is this tries list has some length, say 0 to x. We have to choose one index out of 0 to x randomly, right? So what we are doing here, random dot randint, this randint function will provide a random integer out of 0 to length of tries list -1. We are doing -1 because the index is starting from 0. So that index will be stored here. Now we have to check whether the triangle which is stored at this index is unstable or not. Now how can we check that? We have this list all signs which is storing all the signs for every triangle. So we can check whether the triangle which is existing at this index has 0 pluses, 1 pluses, 2 pluses, 3 pluses. You know what I mean. We will count the number of plus there, positive signs there. So accordingly we will judge whether the triangle is unstable or not. Let's see how do we do that. So what we'll do, if all signs, the triangle which is available at this index, all signs index dot count, we have to count the number of plus there. If this is equal to 2, or if this is equal to 0, that means the triangle is unstable. So we can write we have this found unstable is equal to true, which means we have found an unstable triangle. In case the number of plus is not equal to 2 or 0, which means the triangle that we found was a stable one. So we'll continue with our loop. Now that we have found an unstable triangle, we have to move it to a stable state. Now how do we do that? Firstly, let me write it here. Move the unstable triangle to a stable state. Okay. Now how do we do this? Firstly, the point to be noted is that there are two kinds of unstable triangles. One kinds of unstable triangles are the ones where the number of positive edges are 2, and the other kinds of unstable triangles are the ones where the number of positive edges are 0. So we are going to take different action in both the cases. So we are going to check in the given triangle the number of positive edges. Based on that only we will move it to the appropriate state. Now if you remember from one of the previous videos, I had explained the two cases of unstable triangles. Let me show you once again. So here you see there are two kinds of unstable triangles: unstable triangle 1, unstable triangle 2. Let's consider this case first. Now this is an unstable triangle where the number of plus is 2. In this case what happens now, this state can be moved to any one of these three states. Now what are these states? In the first case what happens, this negative sign between a to b, this negative sign has become positive and the rest signs remain the same. In the second case, this minus and plus remain the same, but this plus sign becomes negative. This is the second case. In the third case, this minus and this plus remain the same here, and this plus sign becomes negative. So basically you see what is happening here. In the first case, this one, this sign is getting inverted. In the second case, the sign of the second edge is getting inverted. In the third case, the sign of the third edge is getting inverted. So basically, if you take this triangle and choose any one of the edge and invert its sign, whatever you will get, that will be a stable state, right? So this is the case of a triangle which has two positive edges. If you go back and see the case of the triangle which has 0 positive edges, the scenario is a little different here. So accordingly we are going to implement as well. So let's try to understand this. In this case, this triangle which is unstable has zero positive edges, that is all edges are negative. Now these three states are the ones which are stable states, which can emerge out of this state. Now what is happening in all these states? In the first state, this minus these two edges are same, and the third edge becomes positive from negative. In the second state, this edge becomes positive. In the third state, a to b edge becomes positive. So basically what is happening here is you choose any one of the edge and make it positive. Whatever state you get will be a stable state. So this is how we are going to implement as well. So you see, the moving of unstable state to a stable state is different in both the cases, when we have zero positives or when we have two positives. So we have to keep this thing in mind while we are implementing it. So let's go back here. Another thing to note here is that there are three stable states corresponding to one unstable state. So we will randomly assign one of the three stable states here. So we will choose a random number here. So we'll again use random package, random dot random. So we want a random integer from 1 to 3. So any one of these three integers can come in R. So if R is equal to 1, we will move it to the first stable state. If R is equal to 2, we'll move it to the second stable state, and so on. So let's handle the first case where the number of positive signs is equal to 2. Let's handle this case first. I'm copying pasting here. So let's see, what do we do if all signs index dot count plus is equal to 2. So as I explained you, the three stable states that can correspond, that can come out of this state. So the strategy that we are going to follow here is that if R is equal to 1, we will invert the sign of the first edge. If R is equal to 2, we will invert the sign of the second edge. If R is equal to 3, we will invert the sign of the third edge. So that's the approach that we are going to follow here. Now how do we invert the sign of a given edge? For that, we should know what is the sign of that edge. How do we get to know what is the sign of a given edge? That detail is stored in G. Basically, G has the detail of the sign of a given edge. And how do we access the edges? These edges we will access from tries list. So let's see how we can do this. So right, if G, so we will pass two parameters here, and the third parameter will be sign as usual. Simple syntax. So what is going to be the first parameter? First parameter is going to be the node of the first edge. How do we access the node of the first edge? All the nodes of the triangle are available in tries list. So we are going to write tries list. Which index? The index, the index that we computed here, over here. So tries list index first node, okay? And in the second parenthesis, what will come? I'm pasting here, tries list index first value, that is the first index basically means the second value. Okay, let me explain it here if you finding it difficult. So tries list is a list of list, and every list is like this. Okay, so 1 will be accessed by the 0th index, 2 will be accessed by the first index, and 3 will be accessed by the second by the index 2, which we are going to use in the next sentence. So this will basically give us 1, and this will basically give us 2. So we are going to pass 1 and 2 to this G to get the sign of that G. Okay, so we'll check whether that is positive or not. If that is positive, we'll make it negative. If that is negative, we'll make it positive. So we'll just copy paste here. So this was positive, so we'll make it negative. Okay, Now the same has to be done with the rest of the edges as well. So I'll copy paste. Okay, I'll remove this. Now this is for the second edge. The second edge will be accessed with index 1 and 2. Here again index 1 and 2. Okay, so again if that is positive, there's one catch here. So see, what we are doing here is, if the sign of the first edge was positive, we are making it negative. But if the sign of the first edge is negative, we have to make it positive as well. So this thing we are going to do in the next statement. So here we are just copy pasting this. Okay, yeah. So let's check this. If the sign of the first edge was positive, we made it negative, and if it was negative, we will make it positive. So we are done with the first edge, and we will handle the first edge if the value of r was equal to 1. What if the value of r is equal to 2? Then we have to choose the second edge. So I'll write else if r is equal to 2, will now handle the second edge. Now again we will check the sign of the second edge. We just copy paste things here. If the sign of the first edge was positive, we'll make it negative, and otherwise I'll just copy paste again. So I'll write left. If it was negative, we will make it positive. Since we are repeating things here, you can also create a function over here so that you pass the values and it makes the changes. I'm just copy pasting here. And the third thing is, if the value of r is equal to 3, we'll choose the third edge and we will invert its sign. So again I'll copy paste the entire thing. So I'll write if r is equal to 3. Now we have to access the third edge, so we'll write 2 comma 0, or you can write 0 comma 2, right? And write 2 0 here, back here. So if it was positive, we made it negative. If it is negative, we made it positive. Yeah, so all set. Now this was the case of the triangles where the number of positive edges were 2. Next we have to handle the case where the number of positive edges is equal to 0. In that case, as I told you, what we will do, we will choose any of the edge. Since all the edges are negative already, we'll choose any one of the edges and we'll make it positive. So the resultant state is a stable state. So what I'll do is, we'll write in the else part, if I'll remove this if. Okay, if the number of positive edges is equal to 0, what we are going to do? Okay, again there can be 3 cases here. Based on the value of r, we will choose the edge. So we'll write if r is equal to 1, we will choose the first edge. I will do that. Else if r is equal to 2, we'll choose the second edge. Else if r is equal to 3, we will choose the third edge. Now how do we choose the edges? The same way that we have done. So like you can choose like this. Now there is no checking here, you just have to make the sign positive because we know that already the sign is negative. So I'll write it here. The sign of the first edge we are making to be positive. Okay, if r is equal to 2, we will choose the second edge, and second edge will be accessed by 1 and 2. Here we'll make it positive, and if r is equal to 3, we will choose the third edge and that will be accessed by 2 and 0 here. Okay, so by doing this we have handled both the cases of unstable triangles, and we have, so basically what we have done in this function, we have chosen one unstable triangle over here. Okay, We have found the index of a triangle which is unstable. Then we are checking whether what is the kind of that unstable triangle. Based on that, we are taking action. Let's go back, sorry. Based on that, we are taking action. If the signs are 2, we are executing this. If the signs are 0, positive signs are 0, we are executing this. So we are done here, and then we will return the updated graph here. Let's go back here and see if everything works fine. So here we were calling this function which we have just now implemented, and after calling this function we are again computing all the signs, and we are counting the number of unstable triangles. This function is returning this variable unstable. We can also keep track of this variable. There's one statement missing here. I'm sorry, we didn't return this variable. We have to return unstable here. Okay, okay, so let's check, let's verify our code. We can check this. Okay, so this is the network that we had plotted, that we had drawn earlier. Okay, this is the output you see. Initially, the number of unstable triangles was 4, and then it became 3, and then it became 0. So this was very small network, so it converged quite quickly. Let's, for example, increase this number of countries to say 8 and see how it works. So this is the network that gets created out of 8 countries, and these are the edges. I am closing it. Here you see, you go up, the number of unstable triangles was 26, then it became 28. You see, after converting one unstable triangle to a stable one, the number of unstable triangles increased to 28, then it reduced, then it increased, and then it decreased. So as you can see, it kept fluctuating. So it keeps fluctuating, and in the end it became 10, and then quickly 0, and then quickly it became 0. If you want, you can also plot this. Let me show you quickly how we can do that. So basically we want to see how the number of unstable triangles is changing when we keep moving one unstable triangle to a stable state in each iteration. So this is the count of the unstable triangles. Let's create a list and keep storing the number of unstable triangles there. So let me create a list here, unstable track, and initially let it contain the initial number of unstable triangles, and as and when in every iteration we are getting the number of unstable triangles, we will keep appending this number unstable to this list. All right, so we'll write unstable track, sorry, unstable track dot append unstable. So this unstable track is a list which has all the number of unstable triangles with respect to each iteration. And if you want to plot, you can plot that as well. So we can do plt.plot. If you want a bar chart, you can do that also. So the function is plt.bar, and it requires two inputs. The first will be the values on the x-axis. So we can have the values to start from 0 on the x-axis. So maybe we can pass a list here. I can write I for I in range. We can just pass the length of this list here so that the number of parameters match. So this was our x-axis, and the y-axis will of course be unstable track, and then we can show it plt.show. So we can check whether it works. Before that, we can use this function so that it asks us for an enter before it proceeds. So let's check the functioning. Okay, we can. So this is the network. Let's close it, and this is the how the number of unstable triangles changed, and I'm just pressing enter here, and this is the plot that we got. So as you can see, the fluctuations that happened in the number of unstable triangles I have not written anything on the x and y axis, but you can understand the y axis means the number of unstable triangles. So it reached here, somewhere here, and then quickly came to 0. So that's how it happens. Okay, let me close it now. Let's go back. Now, if you want, you can also keep printing this list, which is all signs, so that you can see how the signs of the triangles are changing. So let me quickly show you that. Now I'm printing all signs. Since we have already seen the plot, I am just commenting this part. And let me increase the number of cities to say 10. All right, so basically we want to see the signs how they are changing from the initial configuration to the last configuration where all the triangles are stable. So let's check this. Okay, this is the network with 10 countries. So it's taking some time. As you keep increasing the countries, it takes a whole lot of time. So from 8 to 10, it's taking quite a lot of time. Okay, it's taking some time. So as you can see, this is the list which is all signs, and once it stops, I'll show you some examples here. It's actually taking a lot of time. Okay, I think I can pause the video and show you the final result. Okay, I'll show you the final result now. Okay, you see, this is the final result. In the end, out of 120 triangles, in the end we have all the stable triangles. And if you go back, I'm just going a little up. Here you can see a number of unstable triangles. For example, here there are two positives. So this is one of the unstable triangles, and there are zero positives here. This is another unstable triangle. However, over time it keeps evolving, and in the end, whatever you get, so this all list is completely stable. There is no triangle which has zero or two positive signs. So this is how it looks like. We can go back here. So we're done with evolving the network from an unstable state to a stable state. As I told you, once a network becomes stable, it can be divided into two groups, two coalitions. I'm not calling them communities for a reason, because we did community division in one of the previous videos, so you should not get confused with that algorithm and this method, because community is basically community detection is completely different algorithm depending on the number of links. Here the network is complete. Here we are concerned with the signs of the edges, so that's why we're not calling them division into communities, we're calling them division into coalitions or groups. So in the next video we're going to divide this network into two groups, given that it has become stable now.